Alright, it's finally the time for your final exam, so I created 2 questions. Those are the questions that I think will test out all the skills that I have taught you, and then also a way to do a real-life application of both softwares, so you will know that if your skill have been applied to the real life, and also is a good way to prove to yourself that you are actually doing this to apply something in real life that you can actually use in real life. So first question is going to be like this. So a credit card validator. So first you want to create a welcome screen with 2 options. The one is validate a number. So if we input it once, you are going to input a number to validate, and 2 to exit the program. So in this case, the program should not exit until the user input 2. So after you input 1, so you get the input, and after you get the input from right to left, so you're going backwards. So all the even digits multiply by 2 and then get the sum. So there are several limitations. So the first limitation is that the first even number is 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The first number is 8. So this is the first digit, this is the second digit, so all the even digits. So 8, 6, 4, and 2. Those are the even digits. So so on and so forth until we reach the last even number. So the last even number is this one, the last even digit. So this should be digit. So this one is the last even digit. So you have to multiply them by 2. So when you multiply by 2, if the number is greater than 9, then get the first digit and then plus 1. So if my product is 13, so no, it can't be 13. So let's put it 18. So if 9 times 2 becomes 18, I will get my 8, and then I add 1. So the digit I got is 8, and then plus 1, so I will get 9 at the end. So, and then that will be your new number when you add it to the sum. And then also from right to left, all the odd digits just get the sum. You don't have to multiply by anything. So the odd number will be 9, 7, 5, 3, 1. So this one is just counting, start from index at the last index and then going to the odd numbers. So when you get the grand sum of the previous 2 numbers, so just add the odd sum and also add the even sum. So after you add the 2 sum, get the last digit and then check if it's equal to 0. So check if it is equal to 0. So if my last digit, so you get the sum, and then you want to get my last digit. So if I get 1926, I'm just going to BS this, and then the last digit is 0. So check if the last digit is equal to 0. So if it is, then check the first digit. So if the first 2 digits is 37, that is American Express card. So this part, all the way until here, is all checking if this card is validated. So if this card is valid, then check what type of a card it is. So my first digit, just check accordingly. So if the first 2 digits is 37, then it's American Express. If it's 4, then it's Visa card. If it's 5, it's Master. If 6 is Discovery. So if none of the matches, it's also an invalid card. And if it does not pass any of the previous tests, it's also an invalid card. So this is pretty straightforward. So then also at the end to ask the user if they want to continue. And then this is my first question. Now let's go on to the second question. So this one is a 3-layer of tic-tac-toe. So player starts at X, and then you want to demonstrate it for this to show them an example of what it looks like. So board 1, so 1, 2, 3 by 3, and board 2, 3 by 3, and board 3, 3 by 3. So in real life, it should look like. So in real life, it should be one board that's 9 by 9, 3 by 3, so total of 9. So one on top of each other. So it should be look like this. And then the winning condition is the same for your ordinary games. So if you get 1, 2, 3, you're having a win here. So if I have 1, 2, 3, there's also a win here. But if 1, 2, 3, this is also a win. But there's one more trick. So if the first 1, 2, 3. If this 3 connects, then it's also a win. So if I have x here, and x here, all on the same column on the 3 layers, then it's also a win. So this is the only type of win that you can get on a 3 layer, and everything else is based on 1 layer type of the matching. So this is pretty straightforward. So I'll put it like this, and then see as a 3 stacking one on top of each other, and the first layer is on the top layer. So this is board number 1. So this is 2, this is 3, this is a 2, and this is 3. So the user needs to specify 3 elements. The user have to specify 3 elements. So first you have to specify which board you're on. So board number 1, or board number 2, board number 3. And after you decide which board you're going to put, let's go on to which column and which row you're going to put. So it's going to be row by column. So the first one have to input what row it is, and then the last element you have to input the column. So make sure it makes sense. So the first row is on the first row. So when I get 1, 1, 1 is the first layer, first row, and first column. So don't have this 0, 0, 0. This does not work, and the user will get confused. You want to make the user understand your program, but not letting them adapt your program. So same apply for the column. So row and column should be the same thing. So, and then I just explained it previously that when you get 3, 1, 2, 3, this is also a win. So make this functionality, and that's it. The x will be going first. So x, 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 this will be a win, and then you have to alternate between the 2 players. So that's basically it for the final exam. You're going to pause the video and then give yourself around 2 hours to do this problem. Actually give you guys 3 hours to do this problem. So when you finish, go pause this video, and then I'm going to explain what the answers are. So I will also going to link this in the video description to have a Google Drive file that you can download, so you can see exactly what I did. So pause the video now, and then I will see you later.
3 hours later.
Alright, now you have finished the final exam. Let's go over the final exam. So the first problem is a validation problem. Now I'm going to copy this, paste it. So first one, the biggest problem you're going to have is to loop through the entire loop. So how to loop backward, and how to multiply, and then how to set up all the conditions to multiply by 2 and then get your real sum and all the grand sum, how to check for what type of card that you have. So open browser. As usual, I'm going to skip my min method. Let's go over next few of them. So first one, the welcome screen. So this is pretty easy to enter a number. So this one's not going to be important. Now from right to left, even digit multiply by 2. So this one's where the thing gets a little bit tricky. So first I have an I, and I also have a holder and sum. So those are the 3 variables I have. Now let's go on to my conditions. I also have the integer multiplied by 2. So this one is, I did not use this variable, so it's not going to be there. Now in here I have a while loop. So when this result end up failing, that's when I exit the loop. But when I have in here is that the input.length should be greater than or equal to 2 times I. So 2 times I is that my I is starting from 1. So when I have my 2, it's going to be like this. I have a series of numbers. 4, 5, 6, 7, 8, 9. So I have 9 numbers. I have my 2i. So as long as this one is less than my input.length, so when I get my 2i should be I index at 2, index at 4, index at 6, and index at 8. So as long as this one is less than 9, it should be working. And now in here I have my input at char at. So my length minus 2i, so my length is 9 here, minus 2i, and my I starts at 1, so first I will be minus 2. So at index 7, 0, 1, 2, 3, 4, 5, 6, 7, 8. So at index 7, I will get my first even digit, and then I will get this digit. I'm going to put it into a validation method. So inside the validation method, I will check it. So if the input is less than 9, I'm going to set it as its original, and then I'm going to return that value. But if it's greater than 9, I'm going to get my first digit value and then plus 1. So if I get 12 and then I got modulus by 10, so 12 divided by 10 is 10. 1 times 10, I have a remainder of 2. So I have a 2 plus 1. So this will give me 3. And I'm going to return that 3 to my original sum. So here, I'm going to modulus by 10. I will get my first digit value and then add 1. And then I make it back to my multiply by 2 value. And then at the end, I'm going to return this value. So this method is going to return that value and then treat this as a integer in this case. And then this integer is going to be added to the original sum, and then the sum I initialized to be 0 for now. And now I'm going to get my second one, my third one, my fourth one. So that'll be it for that. And this one, I'm going to have a total of 1, 2, 3, 4. So I'm going to I have to validate it 4 times because it's going to be having 9 values from 0 all the way until 8, so I have to divide this by 2. I'll get it end up of 4 times. So 1, 2, 3, 4. After 4th time, it's going to be breaking the loop. So this loop will be break, and then it will return my sum. And this is the right to left even digit multiplied by 2 sum. So this is my first sum that I'm getting. And then next one, I'm going to get my next sum. So my next sum will be the odd digit from the right. So in this case, I'm going to give you starting from 0 and then n equal to 1. So the even number, it will be 2 times I, that's the even number, and then all the odd number is 2 times n minus 1. So 2n minus 1 will always give you an odd number, and 2n will always give you an even number. So that's pretty self-explanatory, because odd minus 1 is always an even, and then an even minus 1 is always an odd. So after that, I'm going to get my input.length minus my odd number. So let me delete this. So this is 6 of them. So input.length minus my first number is 1 minus 1 and minus 3 minus 5. So input.length, 1, 2, 3, 4, 5, 6. So from 0 to 5. And then my input.length will be 6, and 6 minus 1, that's my last digit. And then input.length minus 3, so because this is 2n minus 1, my n is 2, 2 times 2 is 4, 4 minus 1 is 3. So 6 minus 3, that's the 3. And then 1, that's 0, 1, 2, 3, 4, 5. So this will give you all the odd digits that you're going to need, starting from the last digit and then going to backwards. And because the input.char at, this will give you a character. Remember that this is a character. And then when you get a character inside your ASCII table, I'm going to show you. So inside your ASCII table, you're going to get your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but your decimal is not starting from 0. Your character 0 is starting at 48. So what you want to do is to get this into you starting from 0. So how do you get this from 0 then? You will get a character. Your character for 0 is the numerical value for 48. So when you subtract this by 48, you will get a character at 0. So this character minus 48 will give you a numerical value of 0. So it's like this. This is your character 0, but this is the same as a 48 in my ASCII value table. So in my ASCII value table is 48. That's a character value 0. But when you subtract this, 48. But when you subtract this by 48, you will get a numerical value of 0, an integer value of 0, but not a character value of 0. So keep in mind for that. When you subtract 48, it becomes a integer value of 0, and this one is what we want. Because this one is a character, and we cannot convert it into an integer without subtracting this. But when you subtract, it becomes an integer 0. So now this is done. You get the sum, and then you plus the holder, and then your I++ until it reaches out of the bound. So when it gets out of the bound, it's going to quit the while loop, and then this is your sum for your second one, the odd digit from right. And then after that, you want to get the grand sum. So this one's pretty easy. So you get the 2 input, and then you put into your new sum and then return that sum. And then you want to do the modulus. So if the sum that you're getting from the grand sum is a modulus of 10, and then you get it equal to 0, so as I said it before, so if I get 1, 2, 3, 4, 0, and then I got modulus of 10, this will give me 0. Because something divides by 10, and then it's ending in 10, it will also give me 10 as a result for my first digit. So we'll get it equal to 0, so your last digit is 0, because this one is divisible by 10, and then it will give you a remainder of 0, and then you can check for what type of card you have. But other than that, you are going to print out this is not a valid card. And then you're going to prompt it back to your menu and then let the user re-input. So if it's equal to 0, your remainder. If it's equal to 0, then going to check validation card and then check what type it is. So if the first one is at 3, so input.character at 0 is equal to 3, the character 3, because you're using character right here. And then your character at 1 is 7, you're still using character at. So if character at 1 is equal to the character value of 7, so if I converted this into an int, this should be an int of 7, the int of a 55. So if I cast this character into an int, and this should not be a character 7, this should be, I believe, 55? Yeah, this should be a numerical value of 55. So this one, if this one's int and this one's int, you can compare it int to int, or you can compare it character to character. Those both should be the same. And after that, so print out this American Express card, and then else, then this is also an invalid card. The first character is character 4, numerical character 4. Then this is a Visa card. If it's 5, this should be 6. So 6 is a Discovery card, 5 is a MasterCard, and else this is an invalid card. And then you're going to always prompt back to the menu. So in the menu, you're going to have get the system in to let the user choose between validated card or exit the program. And then you're going to print out a menu choice and then let the user input a choice for the menu. So if input equal to 1, so welcome, and then do the scanner again, do that thing again. So this one should all be in main, and then in this case I'm going to have a menu, and then it's going to execute what's in main again. So every time it calls in here, the main menu will only execute it once, but here it will become a loop. So if it's equal to 2, then exit the program, and then if it's not anything other than 1 or 2, then it's going to be invalid input, and then recall the menu option to re-input it. And now let's go back to the main program. So in the main, so I'm actually having a lot of extra things. This is the only thing that you need. Let's delete this. So first, I'm going to go from the most inside and then go all the way out. So first one, you're going to have this one. So you get the input, and then from the right to left, even digit multiplied by 2. Of my input, I'm going to validate it to check from my last digit, and then going back for the even numbers to check them, and then get my sum. And then I will also get my odd digit from the right to get this sum. So those two sums, I'm going to put it inside a grand sum. So this grand sum method will have two parameters, to have those two parameters to add them together to return a new sum. So when you get a new sum, I'm going to pass into a modulus method. So this modulus method is going to check for the modulus by 10. If it's modulus by 10 have a remainder of 0, then I'm going to check what type of card it is. And then that's basically it for this. There's nothing else more. And then I also pass in another parameter. I have the sum I validated for remainder of 0, and I also input the input that the user had input the first time. Because inside here I'm going to still need the character at which index it is to check out what type of card they have. Because this one I only have a grand sum, I'm not going to get my original data for my credit card, so it's not going to work. I'm going to need my original input for my validation to which card they have. So this is the first problem. Now let's go on to my second problem. Okay, so this is my second problem. Now let's close all this. So here is a lot of things that you have to keep in mind. So first, let's go on to the welcome message. So let's play tic-tac-toe, and then the first person will start with the symbol X, and then player must specify 3 elements of the row, column, and board numbers separated by space or entered separately. So one unique feature is that you can win by connecting 3 boards in the same row and column like this. So I'm going an example to print out my array, print out my 3D array. So 2D array and 3D array, they're working both the same way. And then now let's start. That's the first that you're going to start with it. So after it starts, it's going to print out a main menu. No, so after it starts, it's going to print out my initial board. So my initial board, it should be like this. So in here I have my counter equals to 2, so it can be any number because I'm using 2 because my 0 is my O and my 1 is my X. So I'm using 2 as my anything else that's other than 0 or 1 to become a blank space. So you know that when you're having a tic-tac-toe board, you have X, you have an O, or you have a blank. So I have anything other than 0 or 1 be blank. So I'm using 2 for here. So in here, I'm going to initialize the board. So in here, in the main method, I create a new 3D array board to have all the empty things. So I'm going to populate it with a counter equal to 2. And then after I initialize the boards, I print out the 3D array. So inside the print 3D array, I'm going to have loop through this. So system out the print board. So my board number, that's my I. So I plus 1, because it's starting from 0, I have to print out I plus 1. So I have my board 1 colon, and then for my row, column, and if that number is equal to 1, then print out an X. If that value is 0, then print out a O. Then anything else, I'm print out a blank. So my 2 should not be 1 or 0. So all my 2's, it should be printing out a blank. That's why I'm having blanks here. All my 3 boards are having all blanks for now because we have not started the game, and then it's not going to have any marks on there. And then print out a line for each time the row finish, and then print out a space before the last row, and then my second board. After I finished initialize the board, now it's going to go into an infinite loop. So inside the infinite loop, I'm going to get my board value, I'm going to get my scanner, and then I have to initialize a counter equal to 0, and then while true. So this is an infinite loop, so I have it in the message title, it's an infinite input loop. So I'm going to get my 3 digits, row, board, layer, row, column. So if modulus equal to 0, my counter modulus by 2, so it can be either 0 or 1. So in this case, I'm using modulus by 2 because my counter should alternate between 0 and 1. So 0 is my player number 1. My counter equal to 1, that's my player number 2. So in this case, I'm going to modulus by 2, so it can only be alternating from 0 and 1. So if it's 0, then I'm having 1, which is an X. So this one was starting from 0, so if 0 modulus by 2, it should be equal to 0. So my first people, so player 1 should be an x. So I'm having my 1 equal to x. So make a comment here, 1 is equal to x. So and then the counter will increase by 1. And then when the counter becomes 1 modulus by 2, so this one is not equal to 0, it's going to be an else. And then the c minus 1, b minus 1, and then c minus 1. This one should be input at O to my original array. And then every time I'm going to print out an array to display the board again, so you will see your progress. Also, I'm going to increase the counter because it's going to be alternate between player 1 and player 2. So I'm going to check my rows, check my column, check my major, check my minor, and check my stacks. So if any of this pass, it's going to declare a winner. So after we go through the infinite loop, we're going to check the conditions. So first condition, check rows. So this one's exactly the same that I taught you for the previous lessons. That I want you to check conditions for the X and O's for the tic-tac-toe, and this one is exactly the same as the previous two homeworks. So this one is just going to be a 3D array. So check my dummy. So you will have the stack, which layer, and then what row it is, and the column 0. And then if the next column is the same as my first column, then go on proceeding. So my column is k equal to 1, so 0 is equal to 1, then my dummy should be at I, j, and 1. So this becomes 0 and this becomes 1, and then I'll check it. So if the k plus 1 is equal to my length, so all the rows are the same, then congratulations, the player. And then get my counter, what counter it is. I'm going to have a parameter for my counter. So what counter it is. So if modulus by 2 is equal to 0, then player 2. Actually, no. So this should be player 1 and this should be player 2. If the counter is modulus by 2 is equal to 0, then it should be player 1, because player 1 should be having the modulus by 0 and it is also going to have x's. So this one is going to win it and going to return it back to the main menu. Inside the infinite loop, if the number is equal to 1, and then when the counter modulus by 2 is 0, that's player number 1. So player number 1 is going to have a value of 1, and then 1 is equal to my x. So player 1 should go first, and then player 1 should be modulus of 2 equal to 0. So column is the same thing. It's just going to my array.length. That's my what layer am I having, and then inside here what row this have, and then at the end now you have a dummy at row number 0, and then I'm having a variable at rows, so k equal to 1. So if my row number 1 in here, I'm having 3 layers. In this case, array.length will be like this. So array.length should be 3, alternating from 0 to 2, and then array.0.length, that's my rows. So array at 0 dot length, that should be how many columns they have. So array.length should be how many layers I have. Array at 0 dot length will be my rows. Array at 0 dot length will be my columns. So column always goes at the last one. So in here I'm having a variable at my rows. So if my column 0, row 1, row 2, row 3, row 4, row 5, if they're all consistent, all the same values, then it's going to determine which number it's going to have. So player number 1 or player number 2 wins. And if any of them fails, if this one's at 1 and this second one is 0, it's going to cancel out this row and starting on the next row again to check for my values again. And that's it for the check columns and check major. Also, starting from layer number 1, so that's the plane. So plane number 0, plane number 1 is going to have a dummy. So check out my JJ. So JJ starting from 0. So demonstrated. Have my rows, columns, J, because you're having only 3 layers, so the J should be starting from 0, 0, 1, 1, 2, 2, 3, 3. If they're equal, then set it equal to my dummy, and then loop it until it reaches at the end. So if all these are circles, then you will determine which counter they have, it wins. And in here, my layers, you only have 3 layers, so array.length, this should be 3, and then it should be alternating from 0 to 2. So 0, 0, 0, 0, 1, 1, 0, 2, 2, 0, layer 0, layer 1, layer 2. So if any of this becomes 1, this is going to cancel all and go on to my second layer, and then check my 1, 1, 2, 2, 3, 3. If one of this one is 1, and they go on to my third one, and then check it again. So none of this succeed, then it's going to cancel out this printout, and then going to break out from the for loop, and then going back to my infinite input loop to input a second number for the user to keep on competing. And checking minors, same thing. It's going to get my layer at what number you have, and then get a dummy to get my last index. That's my last index. And then going to get my dummy for int I.length -1, I greater than or equal to 0, I minus minus. So in this case, my I should be column should be decreasing, so column goes that way, and then my J should be increasing, so J goes down. That's the row goes downward, and then my column, that's my I, goes to the left. So this one followed by this one, followed by this one. If any of them failed, go on to my second row, just go on to my second layer and check, and that's it. And then finally for the third one, checking for stacks. So this was pretty interesting. So in here I also have 3 loops. So first you set the dummy equal to ij0, so the first one, layer 1, first column and first row. Then my k, that's my layer, that's my first index, so this one will loop through the fastest. So that's my k will loop through the fastest. So k ij, the first one, is the same as my second layer at index ij, and then my third layer at index ij. So if they're the same for the 3 rows, and because the k plus 1 equal to my length, then congratulations, what player it is. What player it is wins. And then if none of the first stack matches, it's going to go through to my one to the right, so this one, and then my second layer, this one, third layer, this one, to check if the 3 are matches. If there are matches, then what counter it is, then display the congratulation message. And that's basically it for this one. Because your k should be the moving the quickest, this one should be checking the most frequently, and that's why the k should be here, and then the k is rolling out the fastest. And if none of them works, then break and then go on back to the infinite loop. So here I have my I always have to pass in my board array, that's my 3D array, and I also have to get my counter. The counter is the alternating between 0 and 1 to determine which player wins. So I think I have some of them that I have not fixed. 1, this is 2. Now let's play this. So get the first one. And now I'm going to get my layer 1, column 1, row 1, column 2. So let's make it to be very straightforward. So I'm going to just win this. And here, player number 1 win because I'm X always goes first, and then player 1 win, and then going to have a menu to 1 to replay and 2 to exit. So this one, you know it works, and then let's go on to my second problem. No, my first problem. This is the second problem. So this credit card, I'm going to get a number and check it. So this is a validated Visa card, and then it actually is. I'm going on a Visa generator site. So this one is Visa, and then I copy down the first one, and they end up detecting this is a valid Visa card. So this one, you know it works, and hope you guys enjoyed this series of lessons. That's the procedural Java programming languages. So now I'm going to go on to object-oriented languages for Java. So Java, this is only the very basic that you're going to learn. So the loops, the arrays, and also the primitive types, the casting, and all the math formulas, and all the math methods and classes. Those are all the fundamentals that you have to learn. Now let's go on to more advanced. That's object-oriented programming, and in there will be much more fun than this one, and then it's going to help you more on the real-life application than the procedural programming. So I will see you in the next tutorial and in another set of tutorials. But until then, stay active, be happy, and play algorithms.